we are looking at the topic bearing and distance. And the first topic we have under this is trigonometric ratios and Pythagoras Theorem. There's no how we talk about bearing and distance and we not talk about trigonometric ratio, because any real life application problem that will come across under bearing will still take us back to trigonometry. And when we talk about trigonometry, what do we mean? We talk about the geometry aspect that talks about a three-sided figure, which is a triangle. And this trigonometric ratio and Pythagoras theorem majorly talks about right angle triangle. In real life, there are cases where we come across right angle triangle, but we've not been noticing them. The first example is in the construction of the staircase. If you have a story building that we want to construct, and we are looking for an easy way to get to the topmost floor without stress, then we look at construction of a staircase. So that is just like the diagram we have here. This is the wall, this is the horizontal ground, then we have the staircase. Also, another example is if you are trying to look at something on top of a tree, if you are standing on the horizontal ground, we need to rotate our eyeball through a particular angle so that our eyeball will so that we'll be able to see the bird that we are looking at on top of that tree. Then we have this type of right angle triangle. This is representing the tree, this is representing the horizontal ground, and this is representing the line of sight that we are using to look at what we have on top of the tree. Then another real life example is this game that we used to play. Example of that is Mario game, all these Subway Surf and so on that we have that are very common now. To jump over an obstacle, we need to move. That thing need to jump not on a vertical line, but on a line that is like this, so as to jump over the obstacle that we are talking about. And that will lead us to the basic things that we need to know under this. And it will lead us to how to calculate the unknown sides and their angles that may be unknown in this. So when we talk about this triangle, when we look at this triangle, the angles of the triangle are labeled using capital letters, that is uppercase letters. But the side that is facing a particular angle is labeled using the lowercase letter or small letters, which you are used to. So you assume that this one is A, and this one is B, and this one is C. When we have something like this that is perpendicular, we call this one perpendicular, and we also call it a right angle triangle. A right angle triangle is an angle that is equal to 90 degrees. Now, when we have a right angle triangle, there is a particular side that is facing that right angle triangle that we have, and that is what we call hypotenuse. Now, if you look at this, if you consider this angle, if you label this particular angle theta, or we can use any other alpha, any other thing to label it. We can use alpha, we can use beta, we can use anything. But I'm using theta for now. So the side that is facing that angle is what we call the opposite side. And the other side is what we call the adjacent side. Now, I said it earlier that we use small letter to represent the side that is facing an angle. So this is angle A, and this is the side facing angle A. I will represent that one with small a. Then this is angle B, and this is the side facing angle B. I will represent that one with small b. And this is angle C, and this is the side facing angle C. And there's something we are used to right from junior secondary classes. That is what we call SOHCAHTOA. And with the help of this SOHCAHTOA, we'll be able to generate the basic trigonometric functions that we have. We have sine, we have cosine, then we have tangent. This sine, cosine, and tangent, we have sine from A. Sine is opposite. I will use the short form. Instead of writing opposite in full, we have opposite over hypotenuse. Now, if we now compare this one and relate it to the triangle we have here. Opposite side, that one is C, and the hypotenuse side, that one is B. From this car that we have here, so that is cos theta. This A is representing adjacent, and this H we have here is representing hypotenuse. Now, if you also relate that to this triangle, the side representing adjacent here is A, and the side representing hypotenuse is B. Then moving to this tour, T here is representing tan, so we have tan theta. O here is representing opposite, and A there is representing adjacent. So if you take that back to this triangle, opposite side is C, then the adjacent side is A. Apart from these three that we have, these are the fundamental ones. We also have another one that we call secant theta. Secant is just the inverse of cosine. Since we've already derived something here that cosine is A over B, secant is just the inverse of cos theta, and we derived something here. We said cosine is adjacent over hypotenuse. So which means what we have here, we have 1, the symbol here is representing division. 1 divided by adjacent over hypotenuse. And this division, we need to change it to multiplication. When we change this division to multiplication, the numerator here will become the denominator, and the denominator will become the numerator. So that will give us 1 multiplied by hypotenuse over adjacent, which is the same thing as hypotenuse divided by adjacent. And if you relate this to this triangle again, the hypotenuse side here is B, then the adjacent side is A. So we can see now that we derive cosine to be A over B, and I said secant is the inverse of cosine. So taking the inverse of A over B, we have B over A. We also have another one that is for cosecant. Cosecant theta, that one is the inverse of sin theta. Now, sin theta from A is opposite over hypotenuse. So when we take the inverse, we have 1 divided by opposite over hypotenuse. So if you change this division sign to multiplication, that will give us 1 multiplied by hypotenuse over opposite. So this one will be hypotenuse divided by opposite, because if you multiply 1 with anything, it will still give us that thing. It will still give us that value. If you multiply 1 by any value, it will still give us the value. So hypotenuse there is B, then opposite is C. So if you look at this and sin theta, we notice that the inverse of this is what is giving us cosecant. And the last one that we have here is what we call cotangent. Cotangent theta, or we call it cot theta. That one is just the inverse of tan theta. And tan theta from there, tan is opposite over adjacent. So by the time we also change this division sign to multiplication, we have 1 multiplied by adjacent over opposite, which is adjacent over opposite. And from there, our adjacent side, if you relate that to this triangle, adjacent is A, then the opposite side from there, that is C. And if you relate this and tan, you notice that the inverse of this, the inverse is simply taking the denominator. Denominator is when we have a fraction like this one, we have a fraction C over A. C is the numerator and AA is the denominator. So when we take the inverse of this, the numerator will become the denominator, while the denominator will become the numerator, and that is what we have done here. So these are the major trigonometric functions that we have. So every other thing under trig ratios, they revolve around these 6 that we have been able to derive now. I got some questions from the audience, and the first one is, what is theta? Now, I explained earlier that we are using alphabet A, B, and C to represent the angles of this triangle. Now, theta is just a term that we use to represent angle. We have theta, we have other ones, we have another one. Alpha is just a way of representing the angle. That is what theta is standing for. Could have used alpha instead of theta. We have another one, we have beta. So these are just like this ABC that we use to represent angles as well. That is what theta, alpha, and beta, that is what they are. Then the second question I got is, what do we mean by SOHCAHTOA? This SOHCAHTOA, they are just the shortened form of the terms that we have here. When I started, I said the side facing the angle 90 degree that we have here, the side facing it, I said we call it hypotenuse. And that hypotenuse, we have the shortened form as HYPA. And I said the side that is facing our angle. Now I'm using theta, as I've explained that theta is just a means of representing our angle. I said that one is the side facing the angle is opposite. We can use that, we can represent that one with OPP. Then the last side, which is the third one, is called adjacent. And we can use ADJ to represent that. So this SA is just representing sine. This OA is just talking about opposite. That H is just talking about hypotenuse. So that is where SO is coming from. Sine, opposite, hypotenuse. And the meaning of this is sine theta is equal to opposite over hypotenuse. That is the simple meaning of that. Now the other one, we have CA. From there, C there is representing cosine theta. Theta is what we are using to represent angle C. A there is representing adjacent. And H there is representing hypotenuse. Then we call it CAH, that is CAH. So which means cosine theta is adjacent over hypotenuse. So whenever you come across a right angle triangle and you know the angle you are given apart from the right angle triangle, which is angle 90 degree, the side that is facing that angle we are given is what we call the opposite side. The longest side, which is the side facing the right angle triangle, which is the side facing the angle 90 degree, is what we call the hypotenuse side. And the last one is what we call the adjacent side. So the last one we have there, we have TOA. From TOA, T is standing for tan theta. That is what it is representing. O is representing opposite. Then A is representing adjacent. Then I got another question again, that what is the meaning of OPP? And what is HYP? And again, what is the meaning of ADJ? So instead of writing opposite in full every time we come across this kind of triangle, we can use the short form. We can use OPP to represent opposite. That is the first 3 letters, the first 3 words that we have in this opposite. The same thing also with hypotenuse. Instead of writing hypotenuse in full every time, we can just use the first 3 letters that we have here. So we have HYP. Then instead of writing adjacent as well in full every time, we can just make use of the first 3 letters. That is where ADJ is coming from. HYP, the first 3 letters of hypotenuse, and OPP, the first three letters of the opposite side of the triangle. Then another question is, what is the meaning of secant? What is the meaning of cosecant? And what is the meaning of cotangent? Now, from what we have here, cosecant is simply 1 divided by cosine. That is the meaning of cosecant. Assuming we have the value of our cos as 2/3, for instance, cosecant of this particular thing, if cos is 2/3, the cosecant is just taking the inverse. What do we mean by taking inverse? 2 here is the numerator, 3 is the denominator. So by taking the inverse of this, the numerator, which is 3, will become our new numerator, that is 3. Then the numerator, which is 2, will become our new denominator. So which means if cosine is 2/3, secant is 3/2. Secant, cosecant, and cotangent, they are just terminologies that we use. They are just terms that we use under this topic. But the meaning of secant is 1/cosine. The same thing also with cosecant. We call it cos. We call it cosec. Cosec is just 1 divided by sine. Or if you have a value for sine, the numerator for sine will become the denominator for cosecant, while the denominator will become the numerator for cosecant. And the same thing also for cotangent. From cotangent, what we can bring out from there is just tangent. So the code there is telling us that we are to divide the value of tan that we have. We are to divide 1 by the value of tan that we have. So assuming tan theta is 7/3, for instance, assuming that is the value for tan theta, then taking the inverse of this, which is the cotangent, this denominator will come up, then this numerator will come down. Then we have that one as 3/7 instead of 7/3 that we have for tangent. Okay. Pythagoras Theorem was named after a mathematician, and the work demanded, he looked at a right angle triangle and he observed that when we have a right angle triangle like this, the square of this longest side, as I've explained earlier, that this longest side that is facing that angle 90 is called hypotenuse. And he observed that taking the square of this longest side, it will give us the same value as taking the square of this and adding it to the square of this. And that is what Pythagoras Theorem is all about. And what am I trying to say is that if this one is A, and this one is B, and this one is C, what the theorem talks about is that the length of this one, which is AC, square of it, is the same thing as taking the square of this one and adding it to the square of the other side. That is what this whole story is all about. So this is the short form, and if you don't want to make use of this AC, combining these ones, we can just go back to what I explained earlier, that the side facing an angle is represented with small letter or the lowercase letter. So this one will be B, and this one will be C, and this one will be A. So which means this one now, AC, that one is B square, AB, that is C square, then BC, that is A square. And this is what Pythagoras Theorem is talking about. So from A, there are some facts that we can derive from A. Now, from indices, we know that anything raised to power 0 is always 1. From logarithm of number, when the log that we are taking and the base, when they are the same, it is also 1. We also have that too under this trigonometric ratio, and that is what I will derive now. Now from there, what we have, if we divide all through by B square, the reason why we are dividing all through by b square is because b is representing our longest side. That is why we are not dividing by c or by a. So if you do that, we have this b square divided by b square is equal to c square divided by b square, which is also the same as a square divided by b square. So b square divided by b square will give us 1. So this one, there is an aspect of indices that says if you have c square over b square, it is the same thing as we take this alphabet without the square, that is c, over we take this other one without the square, b, then the square, since this is square and this is square, we can now collect the square together and we have it as c over b square. Example of this is if you have something like 4 square divided by 5 square. For instance, 4 square is 4 multiplied by 4, which is 16. 5 square is 5 multiplied by 5, which is 25. So the same thing, if you make use of this one too, we have 4 square, which is also 16, and 5 square, which is also 25. Then from there, we have this one as c over b raised to power 2, then plus a over b raised to power 2. And from what I derived earlier, I said sine theta is equal to c over b, and I was able to derive this too, that cos theta is a over b. So if you replace c over b that we have here with sine theta, and we replace a over b which is here, since a over b is the same thing as cos theta, instead of writing a over b again, we can bring in cos theta. It's just replacement. So this one, instead of writing c over b as well from here, we can replace that one with sine theta. So that is what will give us 1 is equal to sine square theta plus cos square theta. So under trigonometry, we have sine square theta plus cos square theta is equal to 1. So at times when we are trying to solve a question, and we get to a point where we observe that there is something like this, sine square theta plus cos square theta. So we don't need to just think and start cracking our brain. We just replace that sine square theta plus cos square theta as 1. Since in the same way, when we come across a place where we have 1 million raised to power 0, we all know it is 1. When we come across a case where we have log 1000 to base 1000 is equal to 1. So we replace those ones with 1. So the same thing under trigonometry, when we have sine square theta plus cos square theta is always equal to 1.